Okay, hi everybody. Hope you're having a great day. We're going to continue on with our lecture series, now talking about concurrent force systems, finding a resultant vector when we have more than two vectors in the system. So this is an example here of a system with three forces. We have F1, F2, and F3. And they're all in relation to, looks like members that come down onto this gusset plate. Now, as you get through what this could be, for example, this could be like a foundation here, and this piece here is a base plate that's anchored in with some anchor bolts, and then this gusset plate here is welded possibly all the way around to the steel base plate. So that's how the load is transferred down into this foundation. Now, when you look at this one, like I say, I always try to give you examples like what I've worked on over my career. This is an example of uplift, because you see all of these forces are pulling up. So what's going to happen is that this foundation that this is sitting on is going to want to try to come up out of the ground. So we're going to have skin friction and or the weight of this foundation holding its stability down to the ground. A lot of times you'll see this on things like roller coaster, amusement park rides, things that have a lot of uplift that want to compress at one point and pull up in tension on another point. So that's a good one. We've got three different arms or pieces coming down. Most likely they're welded around here. They're welded into this plate. That's how they're held to the foundation. And we see that we have 40 kips, or check that, that's kilonewtons. So 40 kilonewtons, 50 kilonewtons, and 20 kilonewtons. And they're all concurrent because they come down and they meet at one point. So there's no rotation from this system. And we got to find the resultant of F1. So we're looking for the resultant vector 1, 2, 3, which is equal to force vector 1 plus force vector 2 plus force vector 3. And we're going to do that in our vector sum, and we're going to use our force triangles. So, like we've done in past videos, we're going to look at this, so we're going to say, all right, this is important to do because we need to take a look at this, and we're going to look at this system, and we're going to say, well, we're going to try to find. Well, let me show you. We're going to try to find some resultant. Who knows where it is? Maybe it's like this. That's the resultant 1, 2, 3. That is the actual direction of the load that is the composite, the vector sum of these three. And that's what you'll be working with in the future. So let's take a look at this. So here's our first force vector. So the first force triangle. So the first one we're going to use F2, and that's vertical, and then this F1, which is at a 60 degree from the horizontal. So that's why this angle is 150, because it's 90 plus the 60 degrees. And then so we go tail to head, and then head to tail here, and then we add those two together. Since those were vectors 1 and 2, we take that as resultant 1, 2. And we use our law of cosines, and we use F1 squared plus F2 squared minus 2 F1, F2 times the cosine of that included angle, 150. And we get that R12 equals 87 kilonewtons. Then we go to our law of sines. And remember, so we're looking for R12, so we take, we know we're looking for its sense. So we've got R12 is 87, and then the opposite angle, so that's 150. Okay, so R12 over the sine of 150 is equal to 40 times the opposite here, which we're calling theta. And that's over the sine of 40. We solve for theta as 40 kilonewtons times the sine of 150 over 87 kilonewtons. We take the arc sine, and we find that this angle theta right here is equal to 13.3 degrees. So we've got a sense and a magnitude of R12. So now that we have R12, we're looking for R123. So we're going to take R12 and we're going to add to it our F3. So we take our second force triangle, and let's look at this. So we've got R12, and we know that R12 was at 13.3 degrees from the vertical. So if that from the vertical was 13.3, that means from the horizontal here, it's 76.7. Because 76.7 plus another 13.3 brings us up to that horizontal, from the horizontal up to this vertical. So that's good. Now we come over here. We know that F3 is based on our original drawing up here is 45 degrees from the horizontal. So we have 45 degrees plus the 76.7, because this is 76.7, which means this is 76.7. So the whole angle is 76.7 plus 45. So now we have that included angle of 121.7. Again, we go to the law of cosines and we take 87 squared, which is our R12, plus 20 squared, which is our F3, minus 2 times R12 F3, cosine of the included angle, 121.7, and we solve for R123 is 99 kilonewtons. Again, now taking our law of sines, we have 99 over the sine of 121.7 is equal to 20 over the sine of what we're calling gamma, solving for gamma, so we're solving for this angle right here. So solving for gamma, we get that it's equal to 9.9 degrees. And if we know that 76.7 plus 9.9 gives us our mapping angle from the horizontal, it tells us that our R123 is 99 kilonewtons at an 86.6 degree angle. So if we go back up here, what's that's telling us is we know that, so this is the horizontal here, and this is the concurrent point. So we know that our angle was, what was it, 86? Go back and look at it, 86.6. So it's 86.6 from there to this point. So slightly less than 90. And we come up here, and it's the 99 kilonewtons. And that's equal to R123. And this is 86.6 degrees. So that's our resultant. This vector right here is our resultant. In other words, that's what this foundation is feeling on an uplift slightly to the left of vertical, worth 99 kilonewtons. That is what this system of F1, F2, and F3 is imparting down here onto our foundation through our gusset plate, through our base plate, and down into the foundation. It's an excellent problem to start understanding why we're doing vector addition or vector mechanics of any kind on a series of concurrent loads that apply the overall resultant. So that's good. I like that. That's a really, really fine example. Take a look at the last one that we did in one of my last lectures, which also was 3 forces, and then take a look at this one and start really understanding how to use a force triangle, the law of cosines, and the law of sines. Okay, I hope that worked out very well for you, and